Okay.
Well, there's a lot of examples.
So we are on page 369, graphs of composite trig functions, okay? So we're going to talk about, let's go ahead and just jump right into examples. Let's see what we find when we try to mix and match some of these functions. So A, we have y is equal to sine x plus x squared. So grab your calculators. Before you plot it, kind of give yourself, think about what it's going to look like. Okay, think about what it's going to look like. Think about what this is going to look like. So you're adding, instead of thinking about this adding 2 sine x, you're adding x squared. Think of it as adding sine x to the x squared graph, right? Because sine x is always going to be between 1 and -1, right? The smaller one, where x squared is going to go like this, right? And it's going to go really high on the ends. So think about what it's going to look like and actually try to graph it. And we're trying to find out whether the function appears to be periodic or not.
A parabola? What does it look like?
Well, it's kind of like a parabola, because it's a parabola and you're adding or subtracting anything between 1 and -1, right? Right, that's what you're doing. So it's going to keep the parabolic shape for the most part. In other words, this guy is really going to dominate this function, right? This is just kind of be a little ripple effect there. Okay, is it periodic? No, it's not periodic, right? Does it repeat itself? Not really, right? Okay, so it's not periodic. B, we're going to do x squared times sine x. There's no way you're going to guess what this one looks like. So go ahead and graph it.
Third axis.
So it goes between here, right? Like this? Right, like that?
Whoa.
Is it periodic?
Yeah. Which graph are we looking at? B, right?
Yeah,
Only B?
Just B. Is this periodic? Is this graph periodic?
No.
Does it repeat itself? The shape does not repeat itself, right? Because they have different amplitudes, right? Okay, all right.
Doesn't matter.
What does yours look like?
Well, mine's just zoomed in. What's their viewing window? Mine's just.
Yeah. So if you change your y to -100 to +100.
What's the viewing window? Oh, plus 100?
Yeah, +100, -100 on the
I
y.
only have like -20.
You have to be in radiant.
You have to be in radians.
Oh.
Next step.
Okay, so this is what's going to look like. We'll talk about this today. Okay, we'll talk about something that looks like this today. Okay, we will. C.
Oh, it did change the radius. Wow. It's unbelievable.
It's almost like kind of important.
This guy.
Out the shoot.
It's a guy I was also just country.
Does this one look periodic?
That one was fun. Very relaxing.
Very relaxing.
Oh no, nothing came up.
It's periodic, isn't it? Doesn't it repeat itself? Does it repeat itself or not?
Yes.
Okay, what about D?
Yeah, okay, cool.
He's not.
Sine x squared. Okay. Of all these, the only one that you're going to find that is periodic is going to be C, right? I believe.
Oh, whoa.
Because D is pretty weird there. So the only one that would really replicate itself is C.
But look at it. Not movie. Yeah, nothing
So-
showed up from.
Let's go and move on to example number 2. Example number 2, we're going to try to actually prove or see what it means to be periodic, okay? So if I had y's, let's consider, or we're considering this again. We already knew, or we kind of saw that it was periodic, right? So what does it mean to be periodic? It means that every period, it replicates itself, right? It's the same thing. So if we assume that this period is going to be 2 pi, because sine x is 2 pi, right? Y is equal to sine x replicates itself every 2 pi, right? Right, every 2 pi replicates itself, okay? So if we call this f of x, then in theory, f of x should be equal to f of x plus 2 pi. Right? Every 2 pi you put in, they should have the same thing. Okay, so let's see if this works. So we're going to go ahead and consider this f of x, okay? And we'll see when we put this in what happens. So this is going to be equal to the same as sine x plus 2 pi quantity squared. So where x is, I'm putting in x plus 2 pi. Realize what I'm doing, right? Okay. But since I know that sine of x plus 2 pi is the same as sine of x, because I know we just saw that sine of x has a period of 2 pi, right? So this is actually the same as sine of x squared, which was the original function, right? This was the original function, so this is going to be f of x. So f of x plus 2 pi is the same as f of x. Okay, so therefore it is periodic with a period of 2 pi. So if this was cosine, it would be the same thing. If it was tangent, well, how would I have to change this? So if tangent, it would be just 1 pi instead of 2 pi, right? Because tangent has a period of 1 pi instead of 2 pi. Correct? Okay, so that's example number 2. Go to example number 3. Okay, and so we're going to go ahead and change this to example number 3. In example number 3, we are going to look at to the third, right? That's what the book says. Sine x to the third. So we're going to do this, and this is going to be to the third instead.
I think the 3 is.
It says sine to the third.
Yeah.
Is that the same thing?
Isn't it?
I don't know.
It is the same thing.
Okay.
Okay, all right. In other words, this is the same as sine to the third x. Okay? So all we're doing is change this to the third. So this is now going to be the third to the third, which is the same as f of x. So again, it's the same exact thing. Really, there's nothing, all we did was change from the squared to the third, right? There's nothing that's that much different here. Okay, so let's go ahead and example number 4, find the domain, range, and period of each of the following functions. Sketch the graph. Okay, so this is actually kind of fun. Example number 4, y is equal to 10x, the absolute value of 10x. So what we would do, we would start with graphing tan x, right? So tangent x looks like this, pi over 2, negative pi over 2.
What's the x maximum for the window?
What?
The x maximum for the window? Or
What do you think? I don't know.
I'm just gonna go.
I would go like 10 to negative 10 or something like that. So this is what the graph's gonna look like, right? This is our graph of y is equal to tan x. Okay. But we're doing the absolute value of it, which means that if it is negative, it becomes positive. So we're going to take whatever is in the negative part and we're going to flip it over. Right? So it's going to look like, exactly, it's going to look like this, right? So these are going to go away. Right? These are all going to go away. It's going to look like this. So the range is what? What is the range of this function?
Greater than 0.
Greater than 0, right? It is bounded below. It has a boundary, cannot be less than 1. Less than 0, right? It has to be either 0 or greater than 0, right? Okay. What is my domain? Is it all real?
Oh wait, no, it's just.
I have asymptotes here, right? It can't be these, right? Okay. So y is equal to make sense? Right? If I added 1 pi, if n is equal to 1, it's this guy. N is equal to it's the next guy. N is equal to 3, right? N is equal to -1, it becomes this guy. -2, it's this guy. Right? Okay, so this would be your domain. Range, talk about boundedness, so we're good there. We're good there. Okay. So that's what tan x. What about sin x? So for sin x, right? And then we're going to take whatever's negative, we're going to flip it over, right? So it's going to look like that. Okay. What is the range? 0 to 1, right? 0 to 1. Right? 0 to 1. Sam, are you there?
Sorry?
Sam, what is the period of this graph? What's the period of this graph?
I don't know. I was busy with another person.
You were what?
I had to talk with someone else.
Caden, what is the period of this graph?
Is it I?
Huh? I think I heard the correct answer. What was it?
2 pi.
No, it is not 2 pi. It's pi, right? Every pi replicates itself, right? Can you see that? Every pi, it replicates itself. So the period becomes now pi. Right? Even though sine was 2 pi, when I take the absolute value, because I flip it over, right, that becomes pi. Okay, that's good. And let's do one more. Let's do example number 5.
Is that all of this section?
No, just when you think you get comfortable in there, we're going to do some different things. Example number 5. In example number 5, we're actually going to add the sinusoid to a linear function. So we're going to have y is equal to 0.5x plus sine of x. So y is equal to 0.5, x is 1/2 x, right? So this is y is equal to 1/2 x. And to this, we're going to add sine of x, right? So it's going to look somewhat, right? Like that. Does that make sense? Right? Because we're adding that, the sine graph to that line there. And you can see that on page 371, figure 4.64. Shows you what that looks like. And we'll take a break here. We'll go ahead and stop, and then let me.
Come up with these windows. Like it's, windows are -2.